As I mentioned in a previous video, the strong nuclear force is a short-range attractive force, and it basically only acts between neighboring nucleons. I mean, that's how short a range it is. It really only affects the neighboring nucleons. But it's an attractive force. It's able to keep the nucleus together. But of course, there's the repulsion, the electrostatic repulsion between the protons. This is a long-range force because there's no limit on how far apart or how near the protons have to be to each other. They will feel that repulsion regardless of where they're located. So there's always this tug of war between the strong force and electrostatic repulsion, and sometimes the electrostatic repulsion wins. And when that happens, it turns out that what we call an alpha particle, which is basically just the helium nucleus, is emitted. Now, let me just go ahead and say real quick, the reason it's called an alpha particle is historical. When they first discovered it, they didn't know what it was, so they just called it the alpha particle. Turns out it was a helium nucleus. But at the time, they didn't know, and the name has just stuck around since then. So we call it an alpha particle. So again, what's happening is this used to be part of the nucleus. But then the electrostatic repulsion wins out for whatever reason. The configuration changes. Something becomes, well, the conditions just become just right, and it gets emitted. And so then it leaves. And so you can see that the nucleus has now lost 2 protons and 2 neutrons. So if I want to write that formula down, so I've got my nucleus, my element, which we'll just say is X. And then up here, we've got the number of nucleons, and down here, it's the number of protons. And as a result of this decay, I've now got 4 fewer nucleons, for my X prime nucleus, and I've got 2 fewer protons. And now I also have the alpha particle. But as I already mentioned, the alpha particle, this is just helium-4. And, you know, sometimes it'll be written this way, other times it's written this way. I believe in the content for this homework, it is written using helium-4. Either way is acceptable. You just need to be aware of that. One thing I want to mention is the alpha particle is generally fired at an extremely large speed. It has a high speed, and this is what makes it dangerous, because that alpha particle flies out. If it collides with anything, for example, if you're standing nearby and it collides with you, that means it's going to be colliding with, molecules inside your body. And if that molecule happens to be DNA, then more than likely will cause a mutation of some sort in that DNA. Now, that could cause the cell to just die. It could cause the cell to mutate in a beneficial way, or in a way that isn't beneficial. It could become cancer. There are a wide variety of things that could happen. You may know more about those possibilities than I do. But in general, it's not something you want to have happen. You don't want to be exposed to alpha decay because in general, it's going to harm you. So real quick, I want to talk about how to enter the answers for this type of problem. So here we go. For example, it says, if the parent nucleus in an alpha decay is Pa231, what is the daughter nucleus? Now, you might be saying, what the heck is Pa231? Well, that's what we've got this wonderful periodic table for. And I have already forgotten, let's see, it was 91. Okay, so we just look for 91. Here we go. Protractinium. Okay. And so I want to get, it says, what is the daughter nucleus? Now, I should mention, this is called the parent nucleus. This is called the daughter nucleus. Okay. So I'm starting out with 231. Protractinium, I believe is what it was. Okay. And then I'm going to lose 4 up top. So this is going to become 227 and 2 on the bottom, 89. And what is 89? I sure don't know. Actinium. So the protractinium turns into actinium. What was that again? Was that AC? So AC. So this is what I want to add, or I should say, I want to put in to WebAssign. I'm just writing this down real quick so that I can add this. We want to put this in WebAssign. So let me go over how to do that. So here we go. So you can see right here, the first two options have got a subscript and a superscript option. It shouldn't matter which order you do them in. I'm going to hit the subscript first, and I'm going to type in 89. And then I'm going to hit the superscript, and I'm going to type in 227. And then I am just going to type in a C. And you can see it gives a little preview there. So everything looks good. 227, 89, AC, submit for testing. And there we go. That's all there is to it.